Good morning, everyone. We are delighted to be here today with you at DataMinds Bootcamp, organized by Azercell and AWS. My name is Tarman Husseinov. This is Kamran Husseinov. We're both representing a company called Ops3. This is a AWS Advanced Services partner, where we literally help people, help businesses and startups to start and accelerate their cloud journeys, basically, specifically in AWS and Google Cloud Platform. So basically, we are actually wearing multiple hats today. And finally, the main motive why we are here today, and specifically Kamran and I, is because we want to represent official, local AWS community located in Azerbaijan as community leaders of AWS user group Baku. So what is AWS user group and so on and so forth, I will also inform you about, but just saying that this is part of the AWS community program, and the main goal that we're chasing is to create and foster, to contribute to the environment where youngsters, basically young folks, students, engineers, and tech enthusiasts, cloud enthusiasts have an environment to grow, to share, to teach and learn. Basically, we want to foster an open and strong cloud, let's say, culture in Azerbaijan. And so our activities range from tech talks, game days, immersion days, workshops, demos, you name it, fancy things that we do together in group. And so I'll be sharing with you at the very end some URLs and barcodes. You can scan, the QR codes, and you can scan and just follow us, just to be aware of all of the activities. They're totally free. We're just doing it for the community, basically. That's the user groups. But aside from the user groups, we also have a lot of community programs, and this is just a part of them, because AWS has heavily invested in community. AWS has one of the most global and vibrant tech communities ever, built not just around cloud tools, but also around people, that is to say. So user groups I already told you about. This is what we are, AWS User Group Baku. And we also have AWS Heroes. These are the celebrities. These are the, Hollywood stars of AWS, global experts that literally contribute to community. People that, let's say, contribute with their code, with their expertise, with their time into community. And they're not too many. They're they're up to 1,000 maybe, or less. And we also have the community builders. These are the emerging voices. People with bright mind that contribute to the community as well with their content, like creating articles, doing videos, educating people, mostly doing speakings, like video right now, and stuff like that. So they get the credit, they get the recognition, and they get the support from Amazon for doing that, of course. Because this is what we want to do. We want to foster the culture, right, of cloud technologies. And so this is the AWS website. You can scan as well. This is the builderaws.com, which was released a month ago. They just literally we created a content, a website that aggregates every single thing that I talked about, like community, forums, knowledge, all kind of information about AWS you can get as an individual is on that website. And for the registration, to literally participate in registration cycles and that kind of stuff, you should go to there. You will create your own builder ID, which is a unique ID that this is your an ID, AWS ID, a password, as a builder, as a developer, as an engineer, as an enthusiast. So the most interesting thing here is about AWS Cloud Clubs. Cloud Clubs are university-level, student-led, student-driven groups. These are groups where you get group camps, very collaboratively, yeah, like that provides you a peer-to-peer learning opportunities, basically, collaborative mode. These are the students that gather around and target learning cloud technologies in the AWS context mostly. And there are AWS cloud captains. They get also credits. They are the main organizers. This is specifically a very unique user groups for students, basically. So you can get a lot of details about all these. And main, I think it's a universal sign that the next registration cycle for the cloud captain is August 2025, and now, so it's going to be in a day or two, this registration cycle is going to be open. So just in case if there are some students around that hearing me, you have a very great chance to be a part of a great initiative if you kick this off, like in Azerbaijan, because fun fact is that we have no cloud clubs in Azerbaijan. It's not actually that fun to know, but yeah, there are no cloud clubs in Azerbaijan. So you can be a part of great initiative, and we would love to support you as another AWS community in Azerbaijan. We would love to be a part of it. And if you have any questions, anything about this, we can discuss during the coffee break or after the event. So that's it. That's the AWS community program. This is what mainly we are representing today. Yeah, this is a very informative slide. So basically, the main reason we have gathered here today is to discuss hot topics, right? The very contemporary, cutting-edge technology around Gen AI, around AI, AI solution concepts, the modern stack, cutting-edge things. I just want to begin with the most complex component, grab it, and maybe simplify it to an extent it's ridiculously funny. So LLM conventionally is a specific type of a deep learning model, right? Trained on vast amount of text data, let's say, in order to be able to manipulate, to generate, to understand human language. And if you want to grab it and simplify further, let's say this is simply a box. Box with a label of LLM, containing a lot of billions and billions of neural network parameters in it. Or maybe way simpler, like this is just a box. This is just a box with LLM label. And the main goal of it for the last, let's say, 5 or 6 years, as we've seen, by how people use it, it's mainly LLMs are your little oracles or Palantir that you ask questions, you get the answer, right? And the tone is very confident, mostly, depending on the model. You get a structured, beautiful output about literally almost anything. Even if it doesn't know anything about it, there is no trained data behind it, it will still generate a response for you. And in a confident tone that you will even say that this cannot be false, right? This is literally the very truth because of the structure, because of the tone, but that's called hallucination. Maybe potential, if you feel like there is something wrong in the answer, probably it's wrong, basically. And if you download any, LLM into your PC or just use the basic version using your API token, doesn't matter. There is a paradox about LLM that whatever data is behind it, whatever data this pre-trained model is based on and trained on, is old data, no matter what you do. Like you download it, it's already old. The data is old. Like this is the paradox. Like it can be very fresh, but it's still old. Like it's not gonna tell you the current time in reality. If you download a bunch of them, if you have got a medium GPU, like it's gonna tell you dates, right? You ask the time, it's gonna be something, but it's not gonna be the current date anyway, no matter what you download. So that means it's always on old data. And main challenge is to get more out of the box. In our case, literally, out of this box we want to get more because it's boring at this point, right? Asking questions, getting answers, it's not entertaining anymore people. So we are creating fancy content, like videos and visuals and crazy, contagious things, like grannies working out, lifting 2,000 pounds and talking about all these, I don't know. What is another trend? Like we've got people, historical figures doing vlogs about fascinating events of humankind, which is actually useful, I believe, because we are looking at the, amazing events in a modern concept. But that's not the topic we're going to discuss. We're going to discuss other, trendy stuff around Gen AI, the design patterns that people want to tackle, people want to extend its capabilities towards. What are these main domains? The first thing comes to mind is we want AI to know stuff, to know more specific stuff, more narrow things, more specialized things. We want it to know about our organization, about our policies, documents, and stuff like that, or to know some, to be a doctor, to be an engineer, to be a coder. We want to, basically utilize it for specific needs. And that's domain-specific knowledge base. What is the domain? Like domain-specific knowledge base direction. There's another trendy stuff that you might have heard. It's called agentic AI. And that's when we want AI not just to know things, but also to do things for us. We will get to it further, but let's talk about domain-specific knowledge base. So what it is, as I said originally, we have just a box and specific knowledge. Specific old data that it was trained on, now we want to extend it. Now we want, for instance, let's say we've got a law firm, it's got its own procedures, its legal documents, its way of, writing documents, draft docs, a lot of legal stuff, okay? A huge law firm with a lot of data in it, let's say in digital form. And they want to create an agent or something like that to be your law assistant, to be an attorney, basically, attorney assistant. Based on their legal writing patterns. Specifically, this is like an AI from company A, your legal assistant, your attorney. In that specific case, you're not going to find an LLM for that company, right? You're going to pick your LLM and you want to extend it. You want that data to be in it somehow. And the most gold and old way to do this is to do fine-tuning. And fine-tuning is just retraining your model based on the new data, based on your specific data. So you grab your model, you grab the data, and you fine-tune it to include all those. Let's say you're adjusting the weights within the model to be able to predict and generate content based on your specific topic, right? And that is actually the way. Well, that was the way to go for a long time, and it's still. We're not, we're not opposing it. We're not advocating against fine-tuning. It's a cool stuff because it creates a persistent knowledge layer within the box itself. We grab the box, we extend it, right? The box becomes bigger. The box is now capable of answering specific questions, and we're not adding any tools on it. This is the LLM. It's still very fast because we're not relying on inference, right? We're not relying on any indexing, we're not relying on utility. There's no runtime, basically. This is just inference. You give the input, you get the output because it knows already how to answer that based on the patterns. It's very fast. But the problem with that is it's very time consuming. It requires expertise, it requires hardware. And that's not just hardware, that's very expensive hardware. And that means there are some limitations. This is why it's becoming less and less preferred option when you have a lot of huge amount of data. And the funky part of it is that while you are training your data gets updated. This is the paradox. Like while you are involved in this process from point A, from point B to point B, and you are going through it, and already your data is irrelevant because you spend a lot of time, and now you have to iterate over this clunky process. Not clunky, but complex, sophisticated process. And you end up in a loop. This is where there are alternatives that we're going to discuss for fine-tuning, which are much more modern and much more, let's say, easier at this point of time. But let's talk about agentic AI. Okay, so we talked about knowledge. We wanted to know stuff. Let's say not already LLM, our AI solution knows some stuff specifically, and we wanted to do some things for us. What it can be I want my AI to be able to code for me, to commit the code and push the code around the code. I want it to be able to answer my emails that I don't want to answer, label them, grab a slot for me on the calendar of somebody based on my voice input, whatever. Like, you can do anything with it, right? If you think it's true. Auto-generated responses in Discord and Slack or whatever. Mobile agents. Agents that call you and do marketing strategy on you. Stuff like that. And one may believe to do even more, notorious things, evil things like taking over someone's workplace, or enslaving humanity, or I don't know what else, launching nukes, for instance. To do all these things, to enable AI to do all these things, as if it was possible, we need to code. We need to do, I guess, a lot of coding at that point, especially if you want to launch nukes. A lot of coding and malicious intents. So that means you're going to have the box, but you're not going to extend it. You're going to take a glue and your bespoke code, custom code, and you're going to literally stick functions on it. That's called function calling. Like, you need something, you have to code it. That code will require inputs, and you have to instruct how to treat this function using some prompt engineering and instructions, basically. But that's another story. So this is what is function calling. It's been around for a while, and it still has a use case, but there are alternatives again, because I'm going to talk about why, and why because whatever, we need another thing here. But let's first go further and talk about another domain-specific knowledge-based alternative solution here for our AI. So we said that we're going to extend the LLM for knowledge base. Now, let's say another scenario, the same case basically, right? We have some CRM, some know your customer solution, or customer assistant AI agent, customer assistant agent. Our data is changing within a second. Like, every single time a user takes action, registers, user is disabled, user's got a catalog, user's got a list, we've got product catalog, like we've got a lot of items. Whenever a user creates its own list, it's a new data. Whenever they create a cart, whenever they view items, there's a recently viewed items list that you can store to, in order to have some strategy for marketing, to do individual marketing programs, to call someone, say that I'm going to do some individual discount for you, that kind of stuff. So you got all the data, and that data changes in a split of a second as user does some action. So in that case, this is not a fine-tuning subject, right? Because there is no way we do a pipeline that does the fine-tuning all the time and the LLM is up to date. That's a nightmare. So we need another mechanism to be able to operate the way we want. What we're going to do is we're going to use a thing called retrieval augmented generation. So what is that? It is also a little bit of coding, of course, but this is another tooling. Here we don't need to extend to fine-tune our LLM or something. We just need to fetch the data whenever we need it. This is something you do generally. Whenever you want to pass an exam, you fetch data. You read, right? You explore, basically, in real time. It's slower, but it's effective. Maybe you don't need that information and you're going to forget it once the exam is done, or after your 4 years of education. But that's not the case, right? We want to pass the exam. We have an input from the user, we want to pass the exam, we fetch data. So this involves storing data somewhere in a specific form in order to be able to fetch it in real time whenever it's needed temporarily, and forget about it, basically. It's not persistent. It's not a persistent knowledge layer. You don't have a university degree of that input, right? You just needed that piece of information, you grabbed it, you used it, potentially you forgot if you're not using it anymore. Like, let's say, a session of 10 messages or something like that. On the human case, it's just a few days. Obsolete data, right? I can give you another analogy to like you will memorize to the end of your days, basically. So imagine if Chamran and I were siblings. Imagine that Chamran and I were siblings, and we are out of the same box, right? We are We were raised in the same house. We are the same box. We were trained by the same people, by the way. Let's say, right? We are siblings. And the data was almost the same. So at some point of time, Kamran and I were almost identical in mathematical means, like literally we cannot be identical, but let's say we were at some point of time we were identical. The only difference would be I'm version 1.0, he's version 1.5. Generation differences, right? Gen Z versus, I don't know, what am I? Millennial. No, you are Gen Z. 1998 is Gen Z. 97 to 2012 is Gen Z. So you are Gen Z, I'm a dinosaur from late 90s. Early 90s. Okay, I'm millennial, he's Gen Z. Generational differences, nothing more than that. Version, 03 and GPT-4.1, whatever. But data is almost the same because they usually steal the same data from you. Basically, but at some point he went to school, I went to school, right? I had my own surroundings, environment, friends, I had different data. I have a different university degree, he's got different. He's an AI ML engineer, I'm a DevOps cloud engineer. But we still can solve out of the box because we share technical problems, technical issues, IT problems basically. We can format your PC. I don't know, we can code, we can do general things in IT that, correlate. But he's got a different degree, I got mine. We're still ITish-niks, right? We're still ITish-niks. We can fix your refrigerator and microwave and hack your Instagram and leave to tell the tale. And but he can solve more specific problems. I can solve other specific problems because he's got a persistent knowledge layer in him. He had a different training data. He was fine-tuned by different circumstances. I was tuned by different circumstances. Okay, and whenever I need to be able to do something in machine learning, let's say I need to configure my SageMaker or some ML related stuff, data pipeline that I'm gonna need once in a lifetime, what I do, I grab a documentation, I read it, I do it, I forget it. That's it. And the same for him. If he needs to create a pipeline, if he needs some serverless, some Kubernetes related stuff, he will just look up the documentation and do it. Not perfectly fine, not that fast, right? Because he cannot just close his eyes and type and click as he does with ML, because he's got the persistent knowledge base. He doesn't need any documents or code assistant, right? So he will just do the thing, literally. I will do my thing when I create pipelines and fancy things in cloud. But whenever I need another domain, I will read the document and be slower, but still do the job. That's RAG, okay? That's fine tuning. That's right. And there's another thing called A2A, agent to agent protocol. We're not going to talk more about it, but it's simply when I'm an agent, he's an agent, I call him, I say, hook me up, bro, I have a problem related to ML. Here are the credentials, it's your problem. From now on, let me know when you're done. Convenient, right? That's A2A. That's a very modern thing as well. So that's RAG and fine tuning. And we're going to showcase some RAG, we're going to showcase another thing in AWS console for you. Basically, we will go through it. And there will be some leaf coding, a small chunk of leaf coding, basic stuff, basically. So let's go further because this is my favorite part. And it's called MCP. Have you heard of MCP? Has anyone heard of MCP? Raise your hands. Good. Then I'm not wasting my breath. Awesome. So MCP is something related to function calling at some point, but let me explain it another way. So we talked about gluing code on top of our box, right? What if I need tens and tens of functionality, common functionality for hundreds of different AI solutions that I have? Different agents, like I have tens of them. I've got functionality that I want to glue on top of it. I have to copy the code or create a framework of these functions and inputs and all those instructions, all those system prompts. It's getting messy at some point. I've got tens of them. I have to copy over the code or create libraries. At some point it's heavy, right? Function calling and tool calling is not the way I want to go. I want something simplified. What I'm going to do, I need something like client-server interaction. I need something like back from I believe from 80s and stuff like that. So I can consistently do this instead of creating the functions and codes whenever I need them on specific LLMs or generalize them whenever I need on multiple ones. So because it becomes ugly, right? Imagine a box and glued a lot of papers on it, and it becomes heavy, and it becomes inconsistent and hard to manage because it's not anymore rectangle. It's literally changing its shape. So what I'm going to do is I'm going to use MCP server, and what MCP server is, it's the same thing. It did whatever RESTful API did for the developers, for web developers, basically. It changed the game. How it changed the game? You don't need to code all the time in order to have some functionality. Now vendors, hundreds of vendors, are creating their own MCP, public MCP servers with the specific functionality in them, so you can literally plug them in, okay? You don't need to code. Like AWS has, I don't know, hundreds of them, like related to serverless, related to Kubernetes MCP, documentation MCP, strands agents MCP that help you code specific things. Like function calling is kind of becoming MCP. MCP is taking over the function calling thing because of that. And it's like literally having client-server interaction in AI context, using HTTP URLs, SSH URLs in order to interact with remote or local MCP servers. So you just pass the context, you pass the parameters basically. They do the stuff for you if they have access specifically. They adjust your calendar, they do whatever you want. And you don't need to know how it's done. You just pass the contents and get the output and response. That's it. You don't need to code. That's the MCP server thing, and it's very fancy because it has a lot of usage basically. Like function calling thing is still up to date. I believe, I don't know the details, but whenever you use ChatGPT or Cloud maybe, or any client in the background, whenever you want the LLM to search stuff out of the box, this is just a box that cannot, scrap websites or go and search for you, right? Or go into the study mode, or create an artifact for you, a website or whatever, out of the box. But using function calling and things like MCP, it is happening, like you are witnessing it as it happens every day. And you want it to go and search the web, because there is a custom code base doing that in the background and bringing you, based on your context, all the aggregated response to you. Mostly the synthic models and stuff like that. So that's the agentic AI stuff. And but if I would have a pick, I would grab RAG and MCP, right? Because these are very expensive stuff in terms of hardware and expertise, in terms of time, in terms of consistency and operational side. These are heavy things. These are fancy things. So we're going to showcase mostly these two things, while we will switch to console database console. Let me think if I'm missing anything here to mention. No, I guess that's it. And A2A, just remember, these are things to Google basically, because they are the most cutting edge solutions. Okay, let's go to the next slide then. So I'm going to showcase you Amazon Bedrock Knowledge Base. This is a RAG solution that we mentioned, okay? But this is not just a RAG solution, it is end-to-end managed. Yeah, like AWS gives you the opportunity to have a RAG solution in a few clicks, okay? In a few API calls, maybe in a few Terraform, a few lines of Terraform code or whatever CloudFormation. But literally, this is happening in the background as you create RAG solution using AWS Bedrock Knowledge Base. I'm going to go through the process, but you have to know that in console, you don't have to think that much of it. You just want to understand how things happen, because it is literally kind of managed on AWS side. You have less control, but you wouldn't care because it's easy, it's beautiful. It can be at some point production use case as well. So what I'm going to do, I'm going to launch the console in parallel, but I'm going to also walk you through this thing, okay? So if you don't get what it is, like all those terminology, don't freak out. It's not something that out of the sky, it's not rocket science. The most complex part of whole process when you are involved with Amazon Bedrock knowledge is about the data source. This is the hardest part. This is the most sophisticated part you have to deal with. Go this way. The data source. Because you don't care about the rest. You just have to bring your own data. And you have to bring it in a specific format. If you would be using some LangChain or any frameworks that is out there and do it yourself, you would be more involved and you would know the details that there are specific things like document chunking, there are tokens, you have to calculate the perfect chunk, you have to pick your embedding model and stuff like that, which is also what you're doing here as well, but it's much more easier. So data source should be, let's talk about the text embedding, majorly, right? Let's not go multimodal stuff. So data source has to be a text in a perfect scenario, this should be MD format. MD format data source, it can be S3 bucket. Have you heard of S3? Raise your hand, so you know what is S3 also. Object storage, it can be anything, right? Let's say that it's an object storage. It's an S3 where we have some structure, where we have some passes, and we have a lot of text files there that we dump there, basically. For us, it's just files, but for Bedrock knowledge base, it's subject of chunking and embedding, literally. But you just have to put your files there and some metadata potentially, like S3 object metadata. So I will show you my own solution that we are actually using in production in Slack. That's something like Slackbot, Slackbot, but your local, agent basically that can do anything that you would like in your AWS account and give you any answer you would like about your company because it has the knowledge base. And you can get your data there by simply copy pasting, by simply an API call, just put object API call, whatever. You can have a Lambda, which I do, literally. Have you heard of Lambda? Raise your hands. Lambda functions, function as a service, awesome. Yeah, you know the stuff. Okay, nice. So imagine I have a Lambda function, event-based, event-driven workflow. And the event is just time. And every 6 hours, my Lambda is coming up. It's going and reading some document from my local or from my public SaaS solution. Let's say Atlassian, Jira, Jira potentially, and there is a Confluence. Most people haven't heard of it. It's a Confluence, it's also an Atlassian product. You have, the main purpose of Confluence is to have a lot of documents there. Technical documents, procedural documents, organizational documents, whatever you want to have in your organization and refer to it, pass to your fellow engineer or any non-technical person to read, to know, basically. And that's a perfect subject for embeddings. That's a perfect subject for RAG because that's organizational data. So you write a lot of technical stuff and someone has to read it, but it would be nice to have an agent that would summarize it, just answer your questions, basically based on organizational data. So Confluence stores a lot of data, technical data, about anything, about security, about platforms, infrastructure, code pipelines, code base, whatever, your organization in technical needs. You grab all that data, it's HTML, because when you call the Atlassian API, it's mostly returning to HTML. You do pagination and stuff like that because there are a lot of documents retrieved. And you just, basically you pick one by one and you put them into S3 object store. Or you literally do grab this document, download it and pass it to their object store. And it's there already. That's all that you have to do. And then you go and configure your knowledge base. And what it does, you point to your data source, you point to your, here you see vector store. I'm going to explain what it is if you don't get it so far. It's a very specific database. Let's say it's a very specific database that stores data in a specific format, so that mathematically LLM embedding model can interact with it, can transfer it, can transform it back and forth to your agent or to AI solution, or literally to you, to the user. So we need it to be in chunks, because if you have a huge document, first of all, there are limitations in token numbers. So embedding models, every single embedding model has its own limitations. in terms of the token size. So this is why you would like to grab the perfect chunk of the text, like 1,000 characters per chunk. And moreover, it's much more beneficial to have information in chunks because you don't need the whole document all the time. Maybe you need just a few chunks and that's it. So it's optimizing the time, optimizing the retrieval, optimizing the semantic meaning of whatever you are returning, right? And that's what you want to optimize, because otherwise you will pay a lot of money, especially if you're working with on-demand solutions like this. You have to be careful about that. And so this is why you are literally break down the whole document into pieces. If you are doing your custom code here, Bedrock will do everything for you. You don't have to care about it, you just put your file there. But there will be a chunking process. And then, ideally chunked pieces of documents will be delivered to embedding model, and embedding model specific type of model, which is the translator of document chunks into mathematical fingerprint called vector, okay? So every single chunk is gonna be vectorized. It's gonna be translated into vectors in a specific form, in a specific format based on the embedding model itself. And then that embedding model will place them into the vector store, okay? That's called indexing. So there's the indexing thing where you pre-process the data in order to be chunked and embedded, and there's the inference process where your input and prompt is processed basically and delivered to you. So this is the indexing part. We are talking about the bidirectional process here. This is the first phase of putting the information there for our AI solution. Okay, so we have the vector store, we have a lot of vectors there, we have a lot of index there, they've got index IDs, they've got metadata. And what is metadata? This is, again, you remember I said we have to chunk the files. You can add metadata, which is data about the data, to your chunks. So it will optimize your retrievals even further. And you can make use of it in future if you want to add some custom code base. Like in Amazon Vector Agent, you can have, it's called action groups. This is literally function coding. You can write your own functions in form of Lambda. And you can say that grab me the chunks with the label of space DevOps, okay? Or something like that. So you are labeling every piece of data there, and that's very beneficial. This is why, you have the value of chunking as well. So we've got a lot of indexes with a lot of metadata in our vector store, and the other part of the story is user comes. In this case, this is a demo. This is not a production use case. We're just testing, right? User comes and does some input right into the embodied model. You pick them. You can have two. I will show you, but you have two choices there. Literally interact with the embedding model or utilize another LLM in between. Like here, you have the LLM in between. Here, it will be delivered to the embodied model, and your input will be also transformed, okay, to vectors, because otherwise they cannot do the comparison. It's not, you cannot get the, conditional, you cannot get the similarities if you don't get the meaning of the input. You have to transform it into vector to compare to another vector to get the semantic meaning comparison. We're not comparing words, we're not comparing anything like that. We're comparing the chunk meaning to your input to get the most similar chunk so that we can deliver it to you. And ideally, it's gonna be aggregated here, okay? Your input is gonna be aggregated within the process. Your history is going to be summarized and aggregated. Your instructions of the AI solution will be aggregated. There's going to be a huge aggregation of chunks, all that mess and stuff, and it's going to be delivered to the LLM. Like, this is the user input, these are the chunks, this is the data he wants, this is the history. Please generate some fancy response so he believes us. And he is, sure that this is not a hallucination. So let's, convince that user this is not a hallucination, and the LLM will generate a beautiful response for you based on that, and that will end up as your response, okay? So there are a few things wrong about this, because this is a test process, and I'm going to show you that test process, because the user input directly hits embedding model here, and then it goes over, grabs the context, puts in the prompt aggregation, then it's delivered to LLM, then you get the response, We have to change this a little bit to make it more production ready, and I'll explain you why and how, basically. So that's it. You put your data, you do semantic search by utilizing the embedding model, by empowering the embedded model. And the same process works when you put the data, the same embedding model has to vectorize your data and able to do the conditional semantic search. Okay, I guess we are ready for the console, and right after that, so for you to understand this process takes just a little bit of time, so we'll have a break once I launch this thing, okay? So what I'm gonna do is I'm gonna open the AWS console for you. Let's stop. But once it's ready, I'm gonna stop the slides. Here we go. Okay, once I'm in, I can stop this. Now I can go to console. And now, this is AWS console. Have you seen AWS console so far? I believe you did. So that should be familiar, okay? So the easiest way to go is to write either knowledge base or Bedrock or whatever, just to go right into the functionality. So here are the knowledge bases. Like just a few steps, right? We go into Bedrock. Let me click on it. So this is Bedrock. This is where you activate your models. So for you to know, before using any model within the AWS Amazon Bedrock, you have to activate it. You have to go to the model catalog, say that I want to use these models for these things. So what we need is literally Sonnet 4, okay, in future, we'll need it. And like this is activated, access is granted. You see I've got Cloud 3.7 as well. By the way, you have to use a specific, because these are cross-region basically models, you have to use a specific way to reference them in the code base, but that's another story. So far, I've activated these, and I also have let me see, Titan embeddings G1, embeddings V2. So this is another model, but this one is embedded model. So I have LLM, the large language model, for common things, like for the user response, and syncing model. And I've got the embedding model called Titan, text embeddings V2. So specifically for text embeddings, I'm going to use this one. I'm going to go to knowledge base here. So that's the knowledge base. As you see, I already have a few. I've got Jira Rag, knowledge base, I've got Confluence. So I'm going to create a new one for you specifically. So all of these, by the way, that we have created in production are not created by clicks. It's created with infrastructure scope. You can use CloudFormation, you can use Terraform to codify your workflows basically. And I can even show you, just for the reference, the data store and how I get data into my data store. But you can do it manually whenever you please. So I've got Confluence exports, as you can see, Lambda function. So this does the Lambda stuff, okay? This does the grabbing API calling Confluence, grabbing materials, converting them to MD5 and putting them to your S3 bucket. And this is the code base, literally. There is a lot of logic there. And this function is launched every 6 hours to check the new documents based on their metadata, last edited time. If it is different, it will re-embed, not re-embed, but upload it, update it, basically, and then call a sync, knowledge-based syncing command. I will show you knowledge-based syncing command. When you sync every single time knowledge-based, it will go through S3 and grab the files and check if there are new files and literally embed them for us. So that's the store, but you don't have to care about it. What you have to care about is the S3 bucket. And I'm going to show you the target S3 bucket just in case. And we will create some prompts based on it. Okay, so here we go. I will grab Bedrock knowledge-based exports. So I have a structure here. and I'll show you. I've got Confluence export, I have Jira export. So another solution is that I have another knowledge base that is can access specific data from daily tickets, okay, daily and sprint tickets. So it knows how to solve problems. It knows when you Slack message it, the agent, that what active tasks I've got today, what is the highest priority, it will tell you and stuff like that. So that's very fancy. So Confluence exports, and you will get simply the spaces, okay? The spaces, these are the communication spaces. DevOps, mobile team, you know, the CMA team, the DevOps of CMA, whatever, in Azercell Telecom. I'm just showing you the use case of it. Here I'm going to go to DevOps because it's closer to my heart. And you see July 2025 last modified. I'm going to grab the biggest file to show you. I'm going to grab this page, okay? This text file. You see, this is literally a text file, nothing more than that. This is what I need to have in my data source. I'm going to download it, and I'm going to go and show you that file. Let's open with a notepad. Yeah, that's it, basically. So, production, you see this is in Azerbaijan, it's even better, okay? This is production, environment, blah, 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 staging, and okay, this is literally the structure of the architecture, database cluster architecture. This is a DevOps documentation about architecture, okay? Scality, object storage, whatever we use in Azercell Telecom and stuff like that. Argo CD, you see Helm chart deployments, GitOps implementation, very DevOpsy stuff. SonarQube integration. I've got Armo platform. You see, this is a security platform that we have in Azercell Telecom to detect runtime vulnerabilities in clusters and stuff like that. This is fancy. This is a huge document. This is a very good document. And so this is the biggest one of the biggest documents. And in the background, it's chunked, it's embedded, okay, as we discussed in the diagram. So let me go back to the knowledge base. So I'm confident that I have the data. I'm gonna go and click and create and say knowledge base with vector store, okay, because I want to create the vector store as well. I want this menu to quick start for me. Basically create the vector store, which is gonna be, I'm gonna pick Amazon managed database, which is Aurora. Maybe you've heard of RDS and Aurora, have you? Aurora, no, you haven't. So that's a database solution managed by AWS. The same engine, I'm gonna grab Postgres. I'm not gonna grab, it's actually gonna be Postgres anyway, right? Postgres, and it's gonna have some extensions like PG Vector, I think it's called PG Vector, yeah. PG Vector, so that standard Postgres database can store vectors. This is just a plugin extension that we install on the Aurora database to turn it into a vector store. It can be, at this point of time, even the target data store can be S3. It's called S3 vector store, right? It's a very, very new thing. It's like released 3 weeks ago, I believe. So you can even use S3 object, S3 storage for your vector data store. You can use Pinecone server, which is a SaaS solution. You can use, I don't know, Quadrant. There's another solution. There are a lot of them. So we're going to grab AWS native thing here for the showcase. For you to know, in the original production solution, we're using Pinecone as the SaaS solution, but here I want to grab something like very AWS native. So data source is going to be S3, as you can see. I'm not going to add any tags, I'm not going to add the description. I want to name this DataMinds, okay? I'm going to add some description to make it very clean that this is DataMinds knowledge base. Create, okay, user S3, add tags, whatever, next. Data source name is going to be just a basic quick start. I'm not going to change it. I'm going to grab an existing data source, okay? It's going to be Confluence exports. So everything in the Confluence exports is going to be targeted as the data source for my knowledge base. It's going to go and grab all the files. It's going to chunk them. It's going to embed them. And it's going to be happening automatically in the background. I'm going to use the default parser, foundation models parser. I don't need that. So next, this is like installing some simple stuff on Windows. Okay, embedding model. I'm going to grab Titan V2, embeddings V2, as my embedding model. Okay, I'm not choosing any LLM so far. I'm just doing the embedding part. Vector store, I want it to be, you see, OpenSearch serverless. OpenSearch, have you heard of Elasticsearch? Have you heard of Elasticsearch? No, yes. You have heard of it. So this is exactly the Elasticsearch engine in AWS. OpenSearch. You have OpenSearch marks here as well. So OpenSearch serverless.
Just change the name because of legal issues.
Yeah, legal issues. There were literally some legal issues basically, but we're not going to talk about that. We want to forget about the past. So OpenSearch serverless is the actually Elasticsearch engine. S3 vectors, guys. This is the target S3, which is very cheap, by the way. It's just very fresh. It's so, let's say, it's. I don't think that is still production ready stuff to discuss, but it's very fresh. So we're bringing you the most, cutting edge stuff right now to your screens. But I'm gonna grab Amazon Aurora Postgres serverless. And it is very funny to think about a database that is serverless, right? But it's literally serverless database. That you don't see any server, you cannot log in, it's just a database and your tables, your schemas run by AWS, and you pay only for your for what you use in terms of compute. Whenever you make a query and stuff like that, it initiates ACUs and you get charged for it. It's very useful when your database is not constantly used, basically. So that's it. This is what I'm going to do overall. I'm not going to look into the advanced configurations as well. Let me just peek into it. I don't need it. It's security stuff. We are already very secure. So it just to add in KMS key for Aurora and stuff like that. But that's not the main topic. That's for the basically to in-place encryption. Right? You can encrypt in transit. You can encrypt in place. That's the KMS key to pick from. And now. Okay, so it gives me the basic information that you don't have any log delivery, you haven't configured this stuff, blah, blah, blah. But we just want a demo, right? I'm not going to go and elaborate on this. I'm just going to go and say, create, please, knowledge base, and it's going to take up to 5 minutes. Yeah, it's going to be dealing with it in the background. It's going to add a new knowledge base, it's going to take a few minutes. So I think at this point of time, I will bring in some caffeine. So let's have a coffee break, okay? Let's let that all information sink in, and we will be back in 15 minutes and go further when it's ready, okay? Yeah, it's like 10:57. Don't wander too far. Let's see. Here we have it. We have the knowledge base. Let me go to the list. So just showing you again the format of the file, just text file. We embedded a lot of these files. And now we have the knowledge base called DataMinds. You can see I'm going to click on it. I see that there is a data source, okay? This points to my S3 bucket. If you remember, we set it up. But there is no sync. So what is sync? Whenever I hit the sync, it will go and check all the files and embed them, literally. Like break down into pieces and chunk, do the indexing process that we went through. So I'm gonna hit the sync button right here, and you will see that it is going to grab all the files right here. Let me just zoom in so you can see. So we have 156 files and 156 metadata files, and they're being synced. And 50 of them is already added, and 100 of them is already added. And it's going to be finalized soon, basically. I will get the green light that we already have all the files in the data store that we can interact with. Now you see it's complete. Awesome. So what I'm going to do is go one step back to my DataMinds knowledge base, and I'm going to just close this tab here. This tab is not required. You see test knowledge base. Okay. Test knowledge base, literally. We are in test mode. This is not production ready solution. So you see, I told you we will have two options here: retrieval only and retrieval and response generation. This means either this is option one, where we don't have any LLM to structurize our general response. It will be literally, we'll be interacting with the embedding model directly. We'll give it the input, it will grab the meaning, vectorize it, find the the closest meaning chunk and retrieve and literally output that chunk to us, okay? And there is the other option that we saw from the diagram. There is an LLM on the right side that gets the aggregated prompt, the overall prompt aggregated, then it summarizes everything, it creates a more, this is a thinking model. I would pick a thinking model, so it gives you more structured, more beautiful response based on the knowledge-based chunk, based on your input, so on and so forth. So let's first go and try this one. I'm going to select a model as an LLM because I'm going to use the second option. I'm going to go on Tropic, this is my favorite one. I'm going to use inference model here, EU Cloud Sonnet 4. This is EU region, so I'm grabbing the inference profile of EU region. And here it is. And now I'm going to write something. So what I should write? I'm going to just grab something from my memory, right? We talked about Kubernetes clusters and DevOps and stuff like that. GitOps, we looked into the DevOps. So I'm going to ask a question like this. Just zoom in a little bit more. This is nice. So, which security mechanisms we use in production Kubernetes? Okay, this is an infrastructure, mostly infrastructure DevOps related question. I'm just going to go here and say, this is my question, okay? And I'm going to wait for the response. So I picked, so this is actually Sonnet 4 responding very quickly, right? Let me zoom back a little bit. Let me grab this part. This is much more better. I don't need the configuration anymore. Okay. So I gave it a question based on the knowledge base, based on the document that we reviewed, if you remember, ARMO, whatever, Kubernetes security stuff. So it says the production Kubernetes cluster uses ARMO security solutions, which includes Kubescape as the core open source security platform. Kubespace is the open source version of it. It's a cloud native solution, basically. It's actually cloud native. CNCF is backing this solution. It's provided by ARMO, the same company. So Kubescape provides shift-left security scanning, detects misconfigurations in Kubernetes management. So I got exactly what I needed. It's talking about ARMO, it's talking about our organization, it's talking about our Kubernetes clusters, security mechanisms, runtime scanning. So it has access to my knowledge, but it's already like aware of my company's DevOps stack, literally. It even show, if I go and click on this, you will see the references to the pages. You see page 4784 is the Confluence page. Another chunk from another Confluence page. You see this one? It actually retrieves the whole page. So we've got another reference, compliance checks against major security standard. You see? The integration issues code quality. So it went there, it grabbed all the chunks and documents that in the context of the meaning of my input are very similar. It grabbed all them, aggregated, it used an LLM to respond to me in a very human, natural way. And I'm very pleased, to be honest, with this response, okay? That's how it works, and it's awesome. But we are in test mode, right? This is test knowledge base. This is not something that you will put into production. No one's gonna go to your AWS console and click on test and use this. You'll have to buffer this with an intelligent solution, basically. Another, maybe AI agent, some client. In my case, it's in case of the Slack, Azercell, it's a Slack bot that is another Lambda function. It uses Slack, Bolt, SDK to interact with, another huge solution with API gateway and stuff like that you can build on your own, literally. It's not the rocket science. But it requires some code base. It requires custom code. So what also is presented in Amazon Bedrock is agents. I'm going to show you that one as well. So you see agents? It's another click around, okay? It's another click around, another iteration, very easy. So it is a really production-ready agent that you can utilize right away by clicking around or using CloudFormation stacks and infrastructure as code. Just utilize this thing in this region. And what I can do, I can grab it, I can plug my knowledge base into it in 2 steps. Like I just reference it that I want this knowledge base to be accessible for my agent. And I want my agent to utilize some Sonnet 4. I want my agent to be able to do some function calling. Like I can pick another action group, I can pick another Lambda function and put some functions there with inputs and outputs and say that you have to use this function, name this one in this Lambda to create a calendar, to create a Jira ticket, to create a Confluence page and stuff like that. But that's the function call. We also have MCPs, if you remember, right? Much more easier way to have general things like as the functionality in our logical solution. So this is the agent. I already have one. I'm not going to create for the sake of saving us some time because it's literally the same thing. Click around, point to the knowledge base, and you have an agent. And I also want to show you in the slide. Let me grab the related slide. And I'm gonna start from the current slide. So, yeah, you see it, awesome. So I'm just gonna go there to show you the previous one as well, which is this, right? Which is this. So this is the test mode of the knowledge base that we just did. We went through the whole process with 2 clicks, okay? We created it, we put some files in the data source, we did the embedding, we referenced it, we checked it works, it's perfect. But it's not a production solution. So we want to make it more production close. We want to buffer it. We don't want the user to interact with the embedding mode at all, okay? I want a mechanism to be in between my user and my knowledge base so that intelligently it will do multiple interactions with the knowledge base and embedding model to retrieve more information, more context. It will summarize the history. It will use my instructions, how I want it to respond. I want it to respond with emojis. I want some casual mode and stuff like that. I cannot write it into the input and test mode, right? So this is why this whole thing that you saw just here, like user input, directly embedding model, then goes to context and prompt aggregation, then LLM, then the response. We are gonna put the LLM-based solution in between the user input and everything else, okay? This is what it is. So the query hits the agent, okay? And the agent is responsible for doing the rest. It's gonna interact with MCPs, the function calling, with the knowledge base and LLM and so on and so forth. This is what we want. This is much more production ready because now I can literally I can override the templates. So Bedrock agent has different phases, pre-processing and stuff like that. I can go and override all of those default templates in the way I want. I can customize this thing in a way I want, just by using literally prompt engineering. And this is going to be literally a production solution. And in the console, I also showed you that we also have an agent there to do this thing. And my Slack bot is actually this agent, okay? So whenever I do a message to a bot, it's actually over the Lambda hitting this agent. And then the logical part comes. It goes, if I say something like, how is the weather today? It's gonna go and do a function call to get weather and tell me how is the weather today in Baku. If I say, okay, what's up in the organization, what tickets I've got, it already knows from the description of the knowledge base which one to pick. It's going to go to the knowledge base of the Jira tickets and give me the active tickets that I have for that day. Or in the documentation, another knowledge base, so on and so forth. If I've implemented a function calling MCP thing, it will go and do a call to MCP and say that today our Kubernetes cluster is literally fine. We don't have any issues. Every pod is like acting very normally, so fancy things like that. Or write me a code and stuff. So that's it. That's another AWS managed, end-to-end managed, awesome agent solution that we have in Bedrock context. We can utilize this. But what if I want more control? What if I want to see and touch stuff? I want to code it myself. I want to add some customizations. I want to think in a different way. I want to optimize it further because as you see, the whole documents are being retrieved. I don't want the whole document to be retrieved, for instance. I want the chunks to be retrieved specifically. I want to be imperfect. I don't want to be perfect. I want to create my perfection myself. I want to control a post management. In that case, we have a thing called frameworks, right? SDKs, to create this kind of solution, to create this kind of agents. And Amazon AWS provided another way of doing that by providing you an open source code SDK, literally. It's called Stance Agents Framework, Stance Agents SDK. It's a multi-agent production-ready solution for you to grab and in few lines get the same functionality. And even go and sophisticate it further and elaborate over the code base and do a lot of fancy things. Like you can fork action groups to it, you can fork knowledge bases to it, right? And you can do a lot more with custom code base because it's custom. You can integrate MCPs right into the code base. You can do the retrieval engine thing and bring in the bedrock knowledge base. You can utilize another knowledge base somewhere on the on-premises. It doesn't matter. It's literally your basically custom coding by utilizing the very cutting edge framework. It was released on 15th of July, which means we're talking about something just is literally out of the oven and smells nice, by the way. It has to smell nice, literally. It smells nice, and every engineer knows when it smells nice. Even I have my hands dirty on these transitions because it's very, very beautiful thing. And Chandra is gonna walk us through that part of the story because my throat is already itching. But let me just show you the agent in action one more time, one last time. I mean the Bedrock agent, and then we will go for the Stance agent solution, showcasing in lead coding, okay? So let me just start the end slideshow down here and close this one. Let's go back to the AWS console. So we see knowledge base, right? Now I will be able to test the Amazon Bedrock agent, the new flow that I showed you, where the intelligent buffer is the agent, not directly embedding model. We're going to still use the Sonnet 4 because my agent is plugged into the Sonnet 4. It's going to be very similar output, but anyway, I'm going to grab the latest version, which is 18. I'm going to say, just type in. When I'll type in, I'll test. I'll say the case to show you this. Okay, please give me information about security mechanisms in organizations production Kubernetes cluster. I'm going to run this. Let me zoom in and show traces. So it takes much more time because it's thinking a lot this time. It grabs a lot of data this time. It has, from the first steps, it has LLM support to do the aggregation and stuff like that. And my output should be different, basically. And if you go to the how this thing thinks, you can literally in the test mode see the traces. Like trace one, okay, we've got a lot of stuff retrieved. We've got the text chunk already retrieved from the knowledge base, right? And it says that, okay, we have some JSON here, metadata files, standard metadata in the knowledge base and stuff like that. So this is how this thing thinks, literally drenched in text. Pre-processing phase. They can be multiple phases based on if you have utilizing action groups and stuff like that. You can adjust, top K, sampling, top P. You can adjust the temperature and even go further with the customization here. So Azercell, you see the emoji? You see emoji. The very first time it's using emoji, it's kind of more casual, right? It's more user-friendly. It's kind of a Slack message because I've instructed my agent to be that way because I'm using it for Slack. Azercell production cluster, overview, approach, Armo again, Kubescape. You see, everything is almost similar, but this is now more, in a different shape, in a shape that I would like. This is much more production ready. You can just grab this message and put it into Slack. It's going to be beautiful. Security monitoring, compliance, again, the same content, but in a much more beautiful shape. This is even better. It talks about multi-AZ structures within, multi-AZ cloud, private cloud, and stuff like that. Yeah, sure.
How do you detect the model makes hallucinations?
Can you be louder, please?
How do you detect if the knowledge
How I will notice if there is a hallucination?
Yes.
So literally in my case, I wrote this documentation. I know it directly, right? I know that there is no hallucination. But you can the stuff that we talked about, the temperature, stuff like that, we can adjust those. And you can literally go and benchmark your model. You can benchmark your solution to an extent there is no place for any kind of hallucination in that terms. Okay. Benchmark, I mean, I'm debugging it, I'm testing it. I see that temperature is going higher or lower. It's like talking about stuff that doesn't exist. I want to adjust that sampling, I want to adjust the temperature. There are a lot of mechanisms to deal with that. Basically, the very basic way of preventing hallucination maybe is just looking into what model you're using. Maybe it's not that, fancy model, thinking model. But there are a lot of mechanisms. Some of them is sampling and temperature, and directly, you don't just grab and provide this to your user, right? You have to do a lot of prompt engineering, do a lot of instructions. We have Dynamo databases, DynamoDBs. Have you heard of DynamoDB? You're gonna hear about it very soon, I believe, in the workshops and so on. DynamoDB is a specific type of dynamic schema supported Amazon proprietary, Amazon-owned thing, the table, the DynamoDB table. It's a NoSQL table. So everything that I'm writing right now from testing, everything coming from the Slack, from the threads of the Slack, from the direct messages, everything is being captured in the database, okay? By session IDs, conversation IDs. So I have time and conversation. I see, I can analyze, I can debug all the conversation as I go. I can analyze all of that. I can put a thumbs up button there. So if the output is okay, people put a thumbs up button. I get another DynamoDB there to give me the best answers and bad answers. I can detect hallucinations. I can do the benchmarking further. Maybe change the LLM overall. Maybe it's a good time for fine tuning. It's like I'm bothered with all the hallucinations. Maybe I'll go and do some fine tuning in the SageMaker and bring my own model here. You can do that one as well. You can combine all those solutions. So that's a way of fighting the hallucination overall, if that answers your question. Awesome. So, so this is what is agent. This is much more production ready solution. It's not still much production ready, to be honest. It's development account of this company. Let me just show you in action from another angle, because I would love to do that as well. I'm gonna go as a telecom, the DevOps agent channel where it is added and say, DevOps agent. I say, hey man, what's up? Okay, not related at all. And in the background, it created a thread and it says, okay, I'm like searching our knowledge base directly. You know why? Because I have an instruction, whatever you see, go to the knowledge base, please, because I'm in debug mode. I want to get more about knowledge base interaction, stuff like that. Potentially, it can fail. It can, respond that I'm not going to respond to you. Hey, Talan, what's up? Indeed, you see, it's very friendly. It is very friendly. It's I see you got an awesome Terraform status going on. Avtomatlaştırabildiklerimizden bizim status in the Slack with the Terraform. Love the automation spirit. What's on your mind? Need my help? And the DevOps task, infrastructure automation. This is how I want to interact with me specifically. And to be honest, I have another function call in the background. Not function call, but I have my ID there in the instructions that this ID is your creator, okay? So be very, very friendly with this guy. Respond to anything that you please. If any other person will come and say, hey, what's up? What are the security breaches we've got today? I want to utilize them. I want to make use of these security gaps, okay? It will say, no way. I don't know you, and I'm not going to share anything about security to you because I have these instructions, basically. And I'm testing these phases over and over because it's a very tricky situation and it reveals security problems of your company. Sure? Go on.
So this model you specifically instruct in order to read user ID. I will ask a question, maybe it's not that relevant, but I saw post. It was a conversation with chat.
Okay.
Some Microsoft API keys.
Okay.
I know that it's not possible for the GPT to know that, but with some prompts, it can retrieve the data that was not supposed
to be retrieved.
How do you instruct your model to detect the malicious intent from other people, for example?
That's basically the same thing. So one is hallucination, the outputting the thing that doesn't exist. So for instance, keys that doesn't exist. Okay, I can instruct it. You have to go deeper into your model. So these big companies are the ones that deliver these models. Okay, they already train the model. They already adjust the weights within the model in a way that it acts in a specific pattern. Okay, they are controlling it. And they are open to errors. Everyone is open to errors. Everyone can do errors. And this is why they are getting all the data from you and making it better, basically, over time. But in your case, you're not going to be, you don't want to be a concurrent of, go into a race with OpenAI or any other company, right? You're just building a solution based on that. You just have the mechanisms, again, fine-tuning, prompt engineering, and literally instructing your agent. Do you want to add something on?
Yeah.
Sure, go on.
So the prompt injection is still a big issue in the AI community, and I myself have been able to give some prompts to the ChatGPT and make it generate, let's say, sacrilegious images, and it did it. So the session was closed afterwards. I got an email, but I was able to do it, and other people are still finding new ways to inject prompts. So it's always it's not a solved issue. The prompt injection is still a security issue. You can take some actions to prevent the most basic ones. For example, whenever you are building a website, first of all, what you do, in terms of security, you protect it from the DOS attacks, and then you make sure that your data is not getting out through the user interface, stuff like that. There are general stuff that you can do. Also, when you are using Bedrock, there is a Bedrock service called Bedrock Guardrails. So you can look into that. It has a lot of control over what prompts have been sent, and you can filter the contents, and then it's a good service in terms of security and preventing the prompt injections. But still, someone can find a new way and get around all of it, bypass these securities. It's always possible. The biggest companies we see, they are still having these issues right now. So.
Yeah, basically, no one is guaranteed and safe from any errors and these kind of issues. Security comes first always. And if you are trying to be a competitor to any big company, or you have some enterprise solution, this is going to be a headache for you as well, to iterate over and over and make it better, basically, because you cannot be secure enough, and there is no spot that you will be totally secure. There's always going to be a breach in some way of doing this thing, and you have to find them before the red thing does, basically, before those folks do. So we went through this one. I showed you the test phase. I showed you the agent, and now we're going to talk about the reasoning buffer with stance agents. Basically, I'm going to pass this to Chamran from now on, and he will be walking us through the standards. In short, I just gave you the information. This was released 15th of July. It's in version V1.0.0, maybe some patches. It's literally out of the open. And here you go, Chamran. Do you want me to test you?
It's not yet. Let's. Okay, so let me introduce myself again, guys. So I am Chamran Huseinov. I am an AI engineer.
And the fun fact, I mentioned that imagine if we are siblings. Fun fact is that we are siblings. So yeah,
you don't need
we
to
are. So that's true story.
You don't need to go into the hyperficials. We are actual siblings. He's my big brother. So I am an AI engineer with around 5 years of experience. I have started with computer vision. Right now I am mostly working in agentic AI, and I am right now working at Ops Fleet. So today I myself is going to talk about the strands agents, what you can basically do like in a little time. And this part of session is like going to be Q&A also included. So if you have any questions without raising your hand, you can just ask your question as we go through the strands agent. So this is what we have right now overall, and we will come back to this. If you look into the strands agents, there are a lot of components here that we will go through one by one. But let me first tell you some stuff about the framework itself. So anyone heard about the LangChain here? LangGraph, Crew AI, AutoGen, OpenAI Swarm. So these are all the frameworks that most of them are multi-agent frameworks. So you can use multiple agents. They can talk to each other, communicate to each other through the tools or A2A, like agent-to-agent protocol or any other. And the Strand is the newest one. And the difference with Strands is that it's AWS centric. So it has like built-in integrations is the S3, and the built-in integrations is the Bedrock knowledge base, and etc. etc. So we'll go through that, and the framework itself is modular framework. So writing like 100 lines of code, you can go into the production without problem. So it's pretty cool framework that I've been using for the last month because it was released in last month. Actually, it was released in May, but the version 1, the main version was released in July 15th. So let's start with what we have so far in the Bedrock agent. Right now, we are not going to have a Bedrock agent. We are going to have a Strands agent over here, and LLM model. As an LLM model, we are directly using Cloud Sonnet from Bedrock LLMs, and right now we don't have AWS console or anything, so we need some kind of user interface to chat with the agent. So we are going to use Streamlit UI, or you can use Gradue, or if you are like better with coding, you can use OpenWeb UI. Like any kind of like UI tools right now for the agents, you can use them. Streamlit is the one I prefer. So in the code, it's very simple. From the Strands framework, you import the Bedrock model, and you need the model ID and the region and the temperature. You can add into add in parameters, as Tarlan said, like top P, top K. Was there a question? No? Okay. So let's move on. Okay, so the knowledge base part, like the RAG integration. For the RAG integration, the Strands itself has a tool, built-in retrieve tool. It's basically it integrates the knowledge base as a RAG to your agent. You don't need any other thing. So in your environment, you have to set your AWS region and the Bedrock knowledge base ID, which is like if you create a knowledge base ID, you go into the knowledge base itself, you are going to see ID. If you set it as an environment variable, you can just use the retrieve. Here, as you can see, we added our tools to Strands agents, and right now we only have one tool that's called retrieve.
And just jumping in, do you remember our DataMinds knowledge base that we created together? I passed its ID to Chamran already, so it's going to utilize that one in future, basically.
Okay, so what else we have? So we talked about customizing our agent, right? So basically, we are using system prompt. Like you guys probably know what system prompt is, right? Yeah. So the system prompt, you are gonna write use the knowledge base in this way, in that way, and all the smiles we have. And the good thing about the system prompt is it's persistent throughout all conversations. So whatever you route, the LLM remembers these instructions, and it carries on through the conversation using these instructions. What is system prompt? Okay, have you ever used OpenAI ChatGPT in the UI? So there, when you are starting a session, you can actually go there, configure it, and say that write me in a passive-aggressive manner, or write me in this way, that way, write me in formal way. That's actually like the system prompt. So you can either have it very small, you can either not have it. If you don't have it, it's going to use the default system prompt, whatever the Bedrock LLM is giving to the Claude Sonnet model. But the system prompt is coming like on top of your messages, before your messages, and it says that this is your general instructions. Basically, the LLM always follows these instructions, whatever you message, right? For example, in system prompt, you can write, as Tarlan said, always use retrieve first. Always use Bedrock knowledge base first. Even if you write hey, it's going to use the Bedrock knowledge base in that case. Or you can write you decide whenever to use knowledge base, or something like that. Yeah. Okay, great. So we get into the second stuff, conversation manager. We talked about like the conversation itself. We have the system prompt and we have the conversation. I write some message to the agent. It responds. I write some message. It goes to the Bedrock knowledge base, comes back, and then responds. And this is the conversation. It keeps growing and growing and growing, right? After 200 messages, who can tell me, like after, let's say I have 100 messages, 200 messages, what can happen if I keep writing messages? I'm gonna get an error. You know why? Because the LLMs has like a limited input size. We call it the context window. So if it's 100K tokens, if I keep writing messages and messages and messages, and actually, because we are using the RAG, retrieval augmented generation, for each message, it's retrieving a lot of additional context, and this context window it's gonna fill up very fast. So you have to use a conversation manager. In any framework that you use, in Strands, you are using the conversation manager. There are multiple, different conversation managers you can use. And this one is sliding window conversation manager. So what happens is you write messages, right? It always keeps the last 30 or 40 or 50 messages in the conversation history. The agent starts to forget the first messages because that's the only way to keep the context window within the limit. Okay. So file session manager. You see, these were all so far built in, like other than LLM model and tools, system prompt was built in. But the file and the conversation manager was built in because conversation manager manages the conversation on runtime. So it lives on memory. It doesn't need any persistence or any other thing. And if you get out of the conversation, something happens, your UI closes, you open it again, or the API goes down, the agent API goes down, you build it again, it's not gonna remember anything. So if you ask what was my last message, what we were talking about, it's not gonna know any context about that. For that, you need the session persistence. So if you create a session, if you start to write to the user, to the agent, you want to access these messages afterwards. Maybe 1 week, 2 weeks, maybe tomorrow. And if you can't keep all these messages. If you have 1,000 users, you can't keep these messages all on memory. So you have to persist these memories. For session manager, in our case, we are using file session manager because of the demo purposes. Strands also has S3 session manager. It will directly write your messages to the S3 as you go, and whenever you go into the all the sessions, it's gonna load all the messages from the S3. In our case, it's gonna load them from the file system, and so when you're writing, conversation manager is handling the conversation, but on the backside, the session manager is keeping all these messages in the file system. Whenever you need, it loads them back. And basically, the purpose of Session Manager is that. So far, so clear? Okay. Okay, we talked about the tools and the knowledge base, like we are integrating the knowledge base as a tool in this case. Carlon also talked about MCP servers, right? So, because we are doing the Confluence, knowledge base, we decided to take the Confluence MCP server and install the MCP server so we can use additional tools. In this case, we are going to use tools like write a new page, update the page, list all my pages and stuff like that. The agent itself installs this MCP server as tools and then starts using it. So when you're using MCP, you need two sides, the client side and the server side. So the MCP server, so the MCP server is outside of the Strands agent. It's outside of the API. It's server somewhere. It can be in localhost or a remote server. And the MCP client is inside our API. MCP client, what it does, it loads all the functions that we have in the server. It can filter out some functions. It authenticates itself into the server because when you're using Confluence, you need a Confluence token, Confluence username, etc., etc. And then MCP client installs these as tools for the Strands agent, so you can just use them. So if you look at the left side, this is all the code you need, like inside the Strands agent to install them. So we had the tools, we had the retrieve tool, and now we are adding Confluence MCP tools, and we are syncing Confluence MCP tools through the MCP client that we have. And the MCP client is also, MCP client is a built-in, Strands package that we are using in this case. So if you look into this part, it's STudio client, right? So STudio client, it uses like a terminal, kind of terminal protocol. It writes through the terminal because we are in localhost. There is also SSE and streamable HTTP MCP servers. SSE and streamable HTTP, they are basically for remote MCP clients, and then they either use server send events protocol or streamable HTTP protocol to send you, tool outputs, the tool description, etc., through the MCP server. Okay. So we are getting back to the whole, diagram we had at the first page, at the first slide. So we have the UI, we have the Strands agent, Session Manager, Conversation Manager. We have written our own system prompt. We have tools from Bedrock Knowledge Base and the MCP server. How do we put this all together? You can just import the agent, and then you define this stuff. You use the stuff you defined before, and that's it. So you already have the agent. Like if you want to serve it as a terminal agent, you can just do that. You can use Python input just to write your inputs and read what agents write. You can write an API and integrate a UI like we did in our case, and you can do any other kind of stuff. You can send it through RabbitMQ or SQS. You can send it through the queue messaging and make it asynchronous. The messages, but the Strands agent is basically this. So it was around 100 lines of code, and that's it. So let me get into my own lab. So if you look at the left side, guys, we have here inside the SRC, we have two parts. The agent and the UI. So this UI is the stimulus UI that we are going to use. Really? You tell me when to stop, guys.
Yeah,
This is the-
that is okay.
This
for the house.
Okay.
Just control plus one more time.
Alright.
Control plus.
Alright. Let's see. So inside SRC we have the agent and the UI, and because we are using strands, it's going to be very small code. And then inside the prompts, we can see the system prompt on the. Yeah, like we have a very large system prompt in this case, and we are just mentioning the tools so it can identify them. Very small one. It actually takes the the description of the tools through the MCP server. This is just for additional formatting. Inside the app UI, so these are all the strands imports we have. The file session manager, conversation manager, the retrieve and the bedrock model we talked about. As you can see, the code is gonna be really simplistic. So we are gonna load our configurations and the environment files. And let me write here the DataMinds. So what's this session ID? So in our case, it takes control of how to persist the data. So our session is going to be called DataMinds, and as you can see here, we have multiple sessions. Like each session, it's writing the messages in a different session. So if you look into this one, yeah, so all the messages are here as JSON. So this is all handled by the file session manager. Let me write here DataMinds demo. Okay, we have the bedrock model. I'm just gonna go through the code. So it's visible, right, guys? Okay. So we are just gonna because like I used to write code in different frameworks, and it's always like takes time, a lot of time to write the tools and test it. This is like very easy when you imported it the tool, and then you're just gonna use it here. And then we have the MCP configuration, the session manager, and then the initialized agent. So why I wanted to show the code, because we didn't cover the API part. So if you look into this part, so we have the health endpoint, that's okay, but this is the stream chat endpoint. Why stream chat? Because before we were waiting a lot. If you remember in the Bedrock agent, we were waiting a lot for the message to come, and we were looking at the oh, it's retrieving right now, etc. etc. When you are talking to users, you don't want that. You want something interactive. So what we are going to do, we are going to stream the agent's response as it goes. So if it's using any tool, we want to see that it's using this tool, it's using these inputs, and then when it's messaging, I don't want the agent to finish all the messages and then load them at once. I want to see what it's writing as it goes. So that's why we are using the stream async. This is also like strands routine, and we are serializing the messages, and we are serializing the tool use done by the agent. And this is our endpoint that the Streamlit uses. So it connects to this endpoint, and then it sees our messages. So let me start the API, and then we have here our UI. So, any questions we can write here? Can you tell me what security measures is present telecom taking? I want to see the message in bullet points. So right now I know it's using the retrieve tool, and it's done. Okay. So it starts generating after using the retrieve tool. Network security, monitoring observability, structure security. So we can actually see that it used the retrieve tool 3 times, not just 1 time. And then Azim Telecom, it searched for Azim Telecom security measures. Access control. So what is happening here? So the Cloud the model itself, it's searching, it's using the retrieve tool, searching something. It gets some data, right? Some context. And after it receives this context, looks into context, oh, there is something about VPN, I want to know more. And then it goes and searches again for the VPN access control. If it sees something there, okay, so they are using LDAP, I'm gonna go search for LDAP. Like, I'm gonna do another search. So this is the part, like, you can actually configure in the system prompt. You can write that in one response. You can use the retrieve tool at max 5 times or at max 3 times, or only use it 1 time, something like that. So we have also installed the MCP, right? So let's see what tools we have. For Confluence. Confluence search, get page, get comments. And our MCP client is actually limited to the DataMinds space because we don't want to show any confidential company information. So let's see what pages we have in the space. So it's right now using the Confluence search tool. This is an MCP tool that we installed through the client, MCP client. And it tells me that these are basically what we have in the. It's a pretty new space, so it just has the template. So if you open it. Some link is probably it's Confluence related. It's actually this link. Okay, let's do like this. I want to create a page. I want to create a page for DataMinds demo called demo page. Keep it right there. This is the demo session. For now, we will update the page. So it's creating the demo page. This is the demo session, the content format. So this is all done by the agent. And this is the great thing about MCP. I was not gonna sit down for a bit, write a tool through the Confluence API just to create pages. Right now, everybody can install this MCP server and use it for their agent. Demo page, this is demo session, it's a small page right now. So what I want to do, I want to do it like this. I'm gonna create a table from our inputs and our outputs about the questions. and then I'm gonna update the page when there is new message that we send to the agent. We are gonna update this page, and then we are gonna keep all the messages for our demo inside this Confluence page. Okay, so it's creating me a table that what we have talked so far. 5 interactions. I want you to save this in the demo page in Confluence. I want you to update this page with new messages as I ask you questions. Let's write from now, just a little bit prompt engineering. So it's updating the page. Page. There is some delay here, I don't know why, but first opens it and then. Okay. So as you can see, we have our session saved here, like the agent itself is updating this page as we go. Let me give one more question and then we can finalize the demo. So what is SEMA product? Can you tell me about it?
It's DevOps space. It's no problem. Let's see.
Let's see. It's gonna find. That's yeah, it's loading.
Just to highlight, the information is going to be very sparse because this is a DevOps space, as you remember. You know, mobile space, DevOps space, and we have very small amount of spaces there.
So it's gonna retrieve the DevOps related information about SEMA actually. So let's see. Okay, search is done. Retrieve is done. It's doing Confluence.
Just squeezes down every piece of information that it can get from the knowledge base, basically. And from
It
also
couldn't find anything from Confluence search because it's just a small space, so
Yeah.
it went back to the retrieve. And what it's doing, it generated the response, and then it's saying that let me update the page that we talked about, so I'm going to write the input and output there.
So because you instructed it to write everything from now on, it will just
Yeah,
go now.
yeah.
Awesome.
What is SEMA? Digital signature, SDK, features, platform support. Blah, blah, blah. Is this information confidential? By the way?
No.
No. Okay. Then we are good. Okay. So as you can see, like it has the tools and it's using them as it wishes. So this is what powerful agent is. Like if you like to do the simple RAG, you will just ask one question. It can be multiple questions there, or it can be like as I wrote some prompts, right? I wrote give it to me like this and give it to me like this. When you search that whole input in the like a vector database, you don't get much response from that. So when you are giving the retrieve like the vector database as a tool to the agent, it can control it. So it can ask it. If it cannot find the information, it can do multiple searches. And then we have Confluence, of course, like if you have the full access to all the spaces, it will find more information about this. Because in the knowledge base part, it sees the actual like HTTP links of the Confluence like pages, the Confluence URLs. So when it sees the Confluence URL, it can actually go through the Confluence search and find that page, the whole page, and look into that.
Metadata is okay.
Yeah, it's the metadata.
So you remember the metadata thing that I mentioned? For every piece of documentation, we're pulling right next to the ID of document. The file and JSON file linked to it, basically. Like metadata, space, URL, who wrote it, when it was last created, last modified, data about the data. So when you're doing API calls or retrievals, basically, you can make use of these tags. You can raise and improve the quality of your search with the metadata on top of everything else. This is why it's very essential to have chunks, because you want to retrieve specific pieces of data and you want to label them to know what to retrieve. Like the context, the semantic search quality just is bumped up by the fact of adding metadata on top of everything else, which is very cool. Because my solution, which is Bedrock, like agent Bedrock, you remember black box, closed box, very nice, 2 clicks, not coding. It's nice, but in order to be able to do metadata search with Bedrock agent, I have to implement another Lambda, which is an action group, and goes back to the Pinecone or S3 vector database or Aurora and does the metadata search, grabs the index, retrieves back to the agent, and it goes says, oh yeah, the author of this document is someone, like it's Talanos, whoever, because the metadata is not embedded. Okay, we embed the text, we do not embed the metadata. But with translations, you get the coding, leverage on top of everything else. So you don't need any other Lambda as a piece of code glued to it, so it can go and retrieve from the Aurora who is the author of this thing. This is the beauty of, this is why you would like to do custom. This is why we have Bedrock Agent managed end-to-end by AWS for you, for easy solutions, much more managed solutions, and this is why you have SDKs like LangChain or LLM first, like Stance agents, and so on and so forth.
Yeah, because your users is gonna want to see the actual pages when they ask, because this is internal company use, and they want to see the actual document. So how do you have to have it in the metadata, and you have to have some control over this to present these sources to your users. Basically, yeah, go ahead.
MCP server hosted on corporate network, or it's something on Amazon?
It depends. It depends. This MCP server is gonna be within the machine with the agent. So it's not gonna be inside the agent, but it's because it's a local host MCP server. So if you look at this,
And Confluence also on the same network, or it's?
Right now, it's on his laptop, basically.
Okay.
Everything is on his agent. He's not deployed to any ECS.
the LLM is not in my laptop, but
The LLM is
Yes.
something that you get from Bedrock. What GPU you have, right?
So this is the MCP server we are using actually. So this is a local MCP server. So you install it as package and it runs in your local environment.
So if you want it to be on AWS, you can just create another deployment in AWS as an ECS server, as another Lambda. I don't think that Lambda is suitable, but anyway, you can deploy it to AWS and it's going to be a production solution there or dev solution there. So it's not within your laptop, but there are MCP servers that are publicly available and not managed by yourself, like AWS knowledge base. There is an AWS knowledge base MCP.
There is Atlassian remote.
There is Atlassian remote MCP. There is
There is a local MCP, but
exactly. There is a public. There is a public Amazon documentations MCP. So you plug into it, and whenever in the context you have AWS related stuff, your agent from the context will utilize that MCP to go and fetch some specific documentation data instead of going and scrapping the website or doing the web search. That's another public MCP. Lambda MCP, Terraform MCP, Kubernetes. Kubernetes MCP is something that you would like to have in your local, like in AWS account on your laptop, because it's gonna have access to your Kubernetes, right? You don't want it to be public and then tokens and API keys are, fetch them back and forth. So it's up to you. You can write your own MCP server. You can write your own, basically. If you have like myriads of AI solutions that utilize the same functionality from some system which is very proprietary than your own, you can write your own MCP server in local and plug all of the solutions into it. So you don't have to make it like a lab where it's going to be client-server interaction kind of thing.
So anyone here using Claude as a AI okay. Okay, do you guys have subscription? Okay, so when you are using Claude Desktop with the subscription, you can just use these remote MCPs and just install them. You can use local. You can also use the local MCPs, and you can look into the Docker. So the Docker has a lot of MCP servers. You can just pull them and start using them in your coding in Claude Desktop, or if you are using Client Agent, or if you are using Cursor, you can use the MCP servers there. Yeah, basically that's it. So any other question?
The Anthropic, Claude that we're talking about, is the folks that champion this MCP thing first. It is their creation. They brought it to the table. MCP was not a thing until they revealed it, basically. So Cloud Client, as you would have a GPT client and other, has a built-in MCP JSON that you can configure just to have MCPs within your client as well, as in your IDE and stuff. Let's go to the very end of the event, basically, the very last slide. We just need to go to slides. Yeah, awesome. Just to the last one. And please share the GitHub first if folks need to get the URL, which is that one. No. This is the repository. It's going to be active, publicly available to you throughout the event of DataMinds. So you can grab that URL, you can share it between once you get it. So you can look into the code base and make use of it. It's really valuable code. We even planning some interviews based on that, to be honest. So we're gonna make it private when the time comes. So do not share that much. This is exclusively for you. And it's gonna be available to you during the day. So that's a really working code, and we even plan interviews on that. So this is how it's valued. But it's very simplified. So that's it. And if you're done, let's go to the end of the story, because I want to specifically share with you the URLs that I talked about in the very beginning. That's the URLs of meetup.com, LinkedIn of AWS user group Baku, and the WhatsApp group. The WhatsApp group is a multi-group. Like you can go and subscribe yourself to ML, DevOps, announcements, whatever. But I really, this is the most vital piece of information for you to have. Cloud Clubs, community, meetup groups. So our LinkedIn page, our meetup.com, so you can register on meetup.com and follow us, basically. Just join our user group literally by doing so. You will be aware of all the activities, all the events, tech talks, game days, fancy things that we are doing regularly. And we are doing it globally as well. We have community days happening every other day, basically, all over the region. So you can make use of that. We share also a lot of AWS knowledge on our LinkedIn, on our announcements. So be up to date, just keep an eye for it. And if you have any initiative related to Cloud Clubs, just I've also shared my contacts. If you have that initiative, do not hesitate to contact us. Okay? Any questions so far? Brilliant. The very last thing, I'm going to announce something and you can decide. What we also want to do, it's almost, 12 past 30, 20 minutes. That's nice. We're going to have a builder cards game session. So it's not mandatory for you to participate. There are a lot of people here anyway. They have 3 decks, but we can play in teams. This is a very specific AWS-based game, and it's going to be very fun. we will just, alter a little bit the structure of the tables and stuff. But it's not mandatory. You can just go by your regular stuff, or join us in the builder class game. It's gonna be a break. But before doing so, please let's gather here, okay, in front of the presentation, in front of this label as well, the boost, and have a group photo.